Hi you guys, this is Miss Claywell. I will be making your videos for Algebra 2 Semester 2 for Summer Academy. So we're going to go ahead and get started on the first lesson, which is function notation and composition. So just to remember what a function is a function is when every input x has exactly one output y. So what this means is the inputs cannot repeat themselves, but the outputs can repeat. So as we go through this, we're going to be looking to see if our inputs repeat themselves and if our outputs repeat themselves. So domain is our input. Do any of my inputs repeat themselves? No. So it is a function. Over here, do any of my inputs repeat themselves? No. So it is a function. So even though my outputs repeat themselves, that's okay because my inputs don't repeat themselves. So if we look at this one, it says that I have my inputs do repeat themselves, and then I have two 2's as an input and two 7's as an input, so this is not a function. If I look at relation 3, my input of b's repeat themselves, so this is not a function. So it is okay for our outputs to repeat themselves, but the inputs cannot repeat themselves. So you guys have probably heard of the vertical line test. What this ends up looking like is if a vertical line hits the graph more than once, it is not a function. If a vertical line hits the graph only once, it is a function. So we don't need to fill in that blank. It is a function. So let's go ahead and look at these. I drew a vertical line. It hit this graph more than once. So this is not a function. I'm thinking if I drew a vertical line through each of these points, so far I've only hit it once. Uh-oh, I see here that there's my inputs repeated themselves. So this is not a function as well. If I look over here, drew a vertical line. This is yes, a function. Here, if I drew a vertical line, it repeats sorry, that's not a very good vertical line. But if I drew an actual vertical line, it would hit twice, so this is not a function. This graph 5 is different in the sense when I draw a line here, it looks like it hits twice, but if you remember, the closed circle means there is a value, the open circle means there is not a value. So there's not two values at this input. Therefore, it is a function. And there's not two values at this input. In this graph, if I were to draw vertical lines, it would not cross it more than once. So yes, it is a function. So now that we've talked about what a basic function is, we're going to talk about how to identify polynomial functions. So it's when the x is raised to a non-negative whole number power. So here this would be like x to the 0, which would just be like a 1 or a constant. Linear function would be x to the first. Quadratic would be x squared, x to the third, x to the fourth, x to the fifth. So notice how all of these are whole numbers, and that is how we know something is a polynomial function. So if I look at number A, I see that this exponent of 5 is actually negative. That would be written as 2x to the negative 5. And if you remember what we just talked about, we decided that negative exponents does not make it a polynomial function. So it may be a function, but it's not a polynomial function. Square root of x, that's the same as x to the 1/2 power. That's not a whole number, so it's going to be no. With these ones, all my exponents are whole numbers and nothing's negative, so it's going to be yes. And even though I have a negative as the coefficient, the exponent is positive, so it's also going to be yes. So this is now we're getting into function notation. It's the idea that this is asking us for our input to be 3. It's asking us to put 3 into the f function. So I'm going to start with my f function. And everywhere I see an x, I'm replacing that with a 3. And then from there, oh, I forgot my squared. I'm just doing order of operations, so I do my exponents. So that's saying I'm inputting 3. The g of 4 is asking me to start with the g function, and it's asking me to input a 4. So everywhere I see an x, I'm replacing it with a 4. So hopefully you guys saw this in Algebra 1. Now this can also correlate to word problems. So this one, I have a plant that's already 9.5 meters tall. It'll grow 7 centimeters a month. The plant height in meters after X months is given by the following function. What is the plant's height after 15 months? So it gave us the input and it wants the output. So it wants to know the height after 15 months is what we're going to try to find, but we're going to start with what h is, and then we're going to input everywhere we see an x, we're going to put that 15 months. Oh. So once we put in that 15 everywhere we see an x, we can enter that into a calculator, and we get 10.55. And if we think about what unit that's in, our output is meters. So it's going to be, after 15 months, 10.55 meters. Okay, so we can also input things other than simply an x. So if we look at what this is asking us to put into g, it's asking us for our input to be a 3a. So everywhere I see a x, I'm putting a 3a. So now I will square that, and then I will multiply that 9a squared by 3. So you can also have your input be something other than an x. This is where like the idea of function composition comes in. So this is asking us to take the s function and inside the s function put a t of 5. So I'm going to find the t of 5 first. So I'm going to find t. Oh. And everywhere I see an x, I'm going to put a 5. So I get -2 times 25 plus 1. That is now my input. So this is asking me to input a -49 wherever I see an s, or an x in the s function. And that gets us to -97. So I know the s function, when I put in a t of 5, I get out -97. So this you would say s of t of 5 is -97. This is a similar idea, just a different notation. this is asking us for, if I started with a W and then put in a U and the 4, this is asking us for U, W of 4. So we're going to go ahead and do this first WU of 4 first. So this notation with the circle, we can rewrite it. So U of 4, everywhere I see an X in the U function, I'm going to put a 4. So now this is really just saying that this is W of -10. So now I'm going to find W of -10. And everywhere I see a X, I'm going to put a -10. And that will get me to -47. So first thing I need to do for this one is find my W of 4. So everywhere I see an X in the W function, I'm going to put in a 4. Guys, I'm still learning how to write with this. If you can't tell, I'll get better. That would get me a 23. So this is really asking for U of 23. And if everywhere I see a 23 in U, or an X in U, I put in a 23. I get out a -48. So the last type we're going to talk about is when we have composition of, we put a function inside of itself. So this is asking for g of x, and that's asking for h of x. Start with the g of x here. So I'm going to start with the g function. And everywhere I see an x, I'm going to put the g function again. And now I just need to simplify that. Well, these 3's are going to cancel out. So I get 4 divided by 4 divided by x. And that simplifies. And I can think of this as 4 over 4 divided by x over 1. Which is the same as 1 over x. If I wanted to do h of x, I would then input, everywhere I saw an x, I would re-input the h function. Then I'd simplify. And I'd end up with 9x 33. No, 34. So we went, these are types of problems that will be in your homework. If you need to go back and listen to this slower, that is fine. Listen to it again. We went through each type of problem that you guys will see. So come to office hours of your teacher, and I'm excited to be doing this with you guys this semester.